Okay, so this problem says apply nodal analysis to determine VL. Now, if you are not told, what method to use to solve a circuit, then you use whatever method seems to make the most sense to you. I happen to like nodal analysis, so it's one that I use a lot. And we want to take a look and see what we can identify. So I usually start off by selecting a ground node. And I usually, if I don't have any reason to do it differently, I usually have the bottom of the circuit be the ground node, just because the way most people draw circuits, it makes sense to do it that way. And then often there will be some voltages that you can label without even, before you set up your equations. So for instance, if I label, if the bottom is 0 and Vx is the voltage across this 4 kilo ohm resistor, that means that the plus side is Vx more than the minus side, or that relative to ground, this voltage right here is Vx, because this side minus that side has to be Vx. Similarly, the voltage right here has to be 1 volt. And the voltage right here has to be 3 Vx. And the voltage right here, I can call that VL, because this is labeled VL, and so the one side is 0, the other side has to be VL. If the bottom side weren't ground, I couldn't call it VL. So when I'm giving it this absolute number right here, it's not really absolute, it's relative to ground. Okay, so now I really just have so I want to take my nodes and set up my equations for each node. So let me start with Vx. So for my Vx, and the way you do nodal analysis is you start at the node that you're at, so it's your node, and this is using KCL, minus the voltage on the other side of the resistor, which you may have a number for, you may have another label for it, divided by the resistance, and that gets you the current. And with nodal analysis, what we're doing is we're adding up all the currents coming out of the node, and so we're defining all of the currents as coming out of the node, and we're summing up all of those currents and saying their sum has to be 0. And the reason the sum is 0 is they're not all really coming out. Some are coming out and some are coming in. But if I draw them all as coming out, then some of them are negative and some are positive, and they add up to be 0. Now, if I had a current source, which I don't in this one, but let's say that I did, let's say this was, this is just an aside. Let's say this is what I was dealing with instead of the one that I actually am dealing with. And I'm looking at writing my node equation for this, this V1 right here. So for V1, I would say my node equation for V1 would be V1 minus 0 over 6, and that gets this current, plus V1 minus V2 over 5, and that gets this current, and then plus 5, because I have a current of 5 coming out of it, minus 2 equals 0, and it's minus 2 because it's going in. So that's how you would write it if you had current sources. but I'm going to erase this now. Are you ready for me to erase it? All right, so now I'm going to write my node equation for Vx. So I'll start by going to the right. So I'll have Vx minus 1 over 2k. And the 2k is just 2000. And then plus Vx minus 0, because the other side of this one is ground, over 4k. Plus Vx minus VL over 3k has to equal 0. Now I can do VL minus 3Vx over 1k plus VL minus 0 over 2k. Just a heads up, I made a math error on this, and so I went back and fixed it. So the rest of this problem is me fixing it. Right here for VL, I got this current, and I got this current, but I forgot to get this current. So that was a big mistake there. So that current would be plus VL minus Vx over 3k equals 0. And then I think I would make just as many mistakes. No, I'm still going to go ahead. Multiply through by the common denominator, so I'll multiply this through by 12k, and that one should be the same as I got last time, so it'd be 6Vx minus 6 plus 3Vx plus 4Vx minus 4VL equals 0. And I'll multiply this one through by 6k, and I'll get 6VL minus 18Vx plus 3VL plus 2VL minus 2Vx equals 0. This top one, that's 9 plus 4 is 13Vx minus 4VL equals 6. Is that the same as we had last time?
Yeah.
Okay. And then the bottom one, negative 18, negative 20Vx. 6 plus 3 is 9 plus 2 plus 11VL equals 0. And now I will use my calculator. I think that's right. Yep. So Vx was 1.04 and VL is 1.9. Okay, questions on that one?